The aim of DSP Lab Experiment 9 is to simulate various audio effects using simulate models. Here we have simulated various audio effects like the echo effect, which is present when there is a source signal is delayed and then added further to the original signal. We have also simulated reverberation effect, which is the case where there are infinite delayed samples with diminishing gains added to the original signal, which can be simulated by an IIR filter. Another sound effect simulated here is distortion, which is simulated by using a saturation block that can clip off certain parts of the audio signal. And the last effect is flanging, which is similar to a chorus effect that creates a breathing like phenomena, which is simulated by using a variable modulation where the modulation varies as a sinusoidal input. This is a first figure which shows the effect of a digital filter on the spectrum and the time scope of a signal.
The discrete Fourier transform of a real-valued signal is conjugate symmetric. The discrete Fourier transform of a real-valued signal is conjugate.
This is without using a filter, and now using a filter we'll see the change in the waveform.
The discrete Fourier transform of a real-valued signal is conjugate symmetric. The discrete Fourier transform of a real-valued signal is conjugate.
We can see here that using a filter, a bandpass filter has made the voice muffled. In the next figure we have implemented reverberation and echo, also using a block of saturation. We'll see the original signal first.
The discrete Fourier transform of a real-valued signal is conjugate symmetric. The discrete Fourier transform of a real-valued signal is conjugate.
Now using the filters, digital filters, we see after processing the audio looks like.
The discrete Fourier transform of a real-valued signal is conjugate symmetric. The discrete Fourier transform of a real-valued signal is conjugate.
So we could see the obvious echo effect in the given signal. The final diagram is a simulation of the flanger effect, and here is a sine wave that creates the modulation and the change in the modulation, and this is the original source file. So simulating this, we can see the output as
the discrete Fourier transform of a real-valued signal is conjugate symmetric. The discrete Fourier transform of a real-valued signal is conjugate symmetric. The discrete Fourier transform of a real-valued signal is conjugate symmetric. The discrete Fourier transform of a real-valued signal is conjugate symmetric. The discrete Fourier transform of a real-valued signal is conjugate symmetric. The discrete Fourier transform of a real-valued signal is conjugate symmetric. The discrete Fourier transform of a real-valued signal is conjugate symmetric. The discrete Fourier transform of a real-valued signal is conjugate symmetric.
Thank you.